Hello viewers, a very good morning to one and all. Myself, I am Ramesh Kumar, Assistant Professor, Department of Computer Science Engineering in KL University. Already it is live. It's live. You can check. Hello viewers, a very good morning to one and all. Myself, I am Ramesh Kumar, Assistant Professor, Department of Computer Science, KL University. I am very happy to share my knowledge on implementation of AI and ML using Python in association with Pantech Solutions, Hyderabad. I welcome you all to this session on implementation of AI and ML using Python. Oh, good. I have opened already. And implementation of AI and ML using Python. What is artificial intelligence? So the word artificial intelligence, it comprises of two words. Already opened PPT. Artificial and intelligence. Artificial refers to something which is not natural. And the intelligence means ability to understand or think. We induce intelligence on the machines. That is the concept of artificial intelligence. We make the machines to think like humans. We make the machine to mimic like human behavior. That is the concept of artificial intelligence. So artificial intelligence is a branch of computer science by which we can create intelligent machines which can behave like a human, think like a human, and able to make the decisions. So artificial intelligence, it is a theoretical concept. We implement this artificial intelligence on machines. Artificial intelligence, it can be implemented. So here there are four different approaches of AI. So first one is acting humanly. So this is called Turing test approach. So it is one of the famous tests introduced by Alan Turing in 1950s. This test is related to artificial intelligence capabilities. So briefly, just we see what is this test. So here there are three participants in this test. One is evaluator A and human B, and there is a machine or a computer C. So the evaluator, he communicates with computer and the human using some text. So then computer and human, they generate the response, they return the answers to the evaluator. Finally, if the evaluator cannot judge who has sent that response, that means this particular machine, it mimics like human, it is giving answers like human, then we say that artificial intelligence is implemented on the machine. So that is the concept of the Turing test approach. So that's what. Here there are three participants in this particular test. A human evaluator, another human, and a machine you want to test. So what is the basic setup required for this setting for this test? The participants are separated. Conversation has to take place in text only channels like screen and keyboard. So the evaluator notes in advance either B or C is a machine, but he doesn't know which one. That is the logic in this test. So the evaluator, he knows, the interrogator or the evaluator, he knows that either B or C, one of them is a machine, but he doesn't know which one it is. So what is the test process? The evaluator can have the conversation with both B and C. Finally, if the evaluator cannot distinguish reliably from the machine, then the machine does possess the artificial intelligence. If we cannot say who has given the answer, either the machine or the human, then we say that that machine has passed this Turing test. The machine has artificial intelligence. So the second approach is thinking humanly. So it is also called cognitive sciences. So we want to induce the intelligence in the computer system. Think like humanly. How our human brain it thinks. In the similar way, we try to make the machine to think like the human brain thinks. That is called cognitive sciences. This is one of the advanced research area. So next one is acting rationally. Rationally means right behavior and right way of thinking. So this is another approach of AI. So doing or behaving rightly, it is a generalized approach and maximizing the expected performance, because if a machine acts rationally, then that performance is optimum. Fourth approach is thinking rationally, law of thought approach this is called. So right thinking, it requires 100% knowledge of the domain, so but it is very complex. But in all these four approaches, research is going on. So then what is machine learning? Actually, there are four different approaches of artificial intelligence as I discussed. So in this, the machine learning, it comes under acting humanly. There are four different approaches of AI. In that machine learning, it comes under acting humanly approach. So machine learning is a subset of artificial intelligence, or it is one of the main branches of artificial intelligence. So it lets the machine to learn from past experience. That is the relationship between AI and machine learning. So AI is a theoretical concept, philosophical concept, and machine learning, it is some practical approach to make the machine mimic like human. Here, what is machine learning? So there are many definitions given by many others about machine learning. So in that, I take few of them. Machine learning is one of the most important branches of AI. So machine learning is the subset of artificial intelligence. So machine learning definition by Arthur Summers, the one of the famous author. So machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. So let the machine learn with past historical data. So that is the concept of machine learning. For example, online shopping. So let's say you want to purchase some items online. Then first we log on to one particular e-commerce website. There first time we search for a particular category of items. So whenever you log on for the second time, automatically it shows the recommendations. How it is happening? So that is automatically it is happening. So the technique behind this is machine learning. Using the past historical data of a particular customer, it will give the recommendations. Like that, there are many applications of machine learning. So here, second, the most popular definition of machine learning, more technical. So a computer program is set to learn from experience with respect to some task T and some performance measure P, and improvement with experience. We need three things. There should be one well-defined task T, and there should be some performance measure, and the performance it should be improved with the experience E. Let me discuss with an example. Let us say we have an email program that watches the emails and it marks as spam or not spam. We can see in our Gmail. So it classifies the mails into spam or non-spam. So there is a program that that email program is watched and to mark spam and not spam. In this, according to the definition, what is task, what is performance, what is experience, let us just understand. classifying an email as spam or not spam, that is the task. It is a well-defined task. And watching you the label emails as spam or not spam, that is from the experience. For example, if a mail comes and in that it will identify some specific terminologies to classify as spam or non-spam. So with experience, the program it learns through experience. And what is the performance measure here? The number of emails correctly it classified as spam or not spam. That is called performance measure. So any machine learning application, we have these three things. One is a well-defined task. Second one is experience. Third one is performance measure. So there are wide range of applications of AI and ML in our real time. Some of them I have just shown here: healthcare, transport, education, electronic commerce, entertainment, robotics, whatnot. Each and every field it is influenced by AI and machine learning. That's why it has become most popular in recent days. So machine learning and our traditional programming approach, there is a slight difference. So in traditional program, we give some input plus program to the computer and it generates the output. For example, we write a program to compute sum of two numbers. So here the input is two numbers and we write some logic to compute the sum, that is our program. Then our computer it generates the output, that is the traditional programming. So then what about machine learning? In machine learning approach, we give the input plus output and it generates a model, hypothesis or a program. That is the difference. So let me give very clear idea on this input plus output. What is this input and output? So for machine learning, data is very important. That is called past historical data. So this data, it consists of number of observations or tuples or records. So these records, they may consist of some attributes or properties. So these properties, they can be categorized into some input and output features. We call it as features, attributes, properties. There are different names. So in every observation, we have some input plus corresponding output. Input and corresponding output. So that is called labeling. The data is labeled as input instance and corresponding output. That is called labeling. So for example, let me take one example. House price prediction. So for example, area, number of bedrooms, how old it is, and what is the price. I take four attributes or four features of particular data. So in that house price, it is dependent on area, number of bedrooms, and the age. So here these three variables are called independent variables, and the house price it is dependent variable. So in every observation, we have some input instance and the corresponding output label. So we feed this to the machine and then it will build one model or a program. And we use that particular model to predict some other unknown value. That is the basic concept of machine learning. So input data plus output label, this is called as data set or example data. So when should we use machine learning? So we might think that we can use machine learning for each and every application. That's not correct. That is even wrong. So there are some applications where we need the machine learning approach. There are some applications where it doesn't require. The first thing we must understand what type of problems we should solve by using machine learning approach. So machine learning is used when human expertise does not exist. For example, navigating on Mars. So here human expertise it does not exist. There we have to use some artificial intelligence and this machine learning. So we know we send some robots onto this Mars machine. we know that we have had in recent days. So a lander that will detect, take the images and analyzing the task, human cannot do it. So where the human expertise does not exist, there we have to use this artificial intelligence and the machine learning. Humans cannot explain their expertise. For example, speech recognition. Speech recognition, it is one of the most advanced research areas in machine learning. So here, it is a very complex task it is. There human expertise, it cannot explain. There we use this artificial intelligence and machine learning approach. So models must be customized. For example, personalized medicine. So based on certain values, we can predict some medical advice to the patients. So that must be customized based on the parameters that medicine should be suggested. There we need the customization. Next, models are based on huge amounts of data, like that your DNA analysis and all. So in this particular approaches, we must use machine learning, where human expertise does not exist. So humans cannot explain with their expertise and customized models and handling large volumes of data and finding the insights. There we need the machine learning. Where we do not require machine learning, very simple. For example, your payroll calculation. Your payroll calculation. So there we do not require any artificial intelligence. That is a simple calculation. We give some values of a salary and all, then automatically it will compute the value of DA, HRA, gross pay and all. There we do not require the machine learning. So we should not think that we can use machine learning for anything. That's not granted. Even we are wasting the computation time of the machine. But there is a wide range of applications in our real time with this machine learning and AI. What are the areas currently in industry, in which areas this machine learning is being used? Just let us have a look. Why this technology is the most popular one. So here there are some applications that are being developed in real-time industry. Some of them I have listed here. First one is web-based search, web searching. There we need some analysis of large volumes of data. We have to search a particular pattern in a huge volume of data, especially in internet environment. We have a huge volume of data where we need intelligent search techniques. Next one is computational biology, for example, genome analysis and all. Finance sector, potential identifying the potential customers and all. So e-commerce, identifying the buying trends of customers and recommendation systems. Space exploration in astronomy. Next, robotics, information extraction. So currently social networks, they have become very popular, and analyzing these particular social networks and all, software debugging of software. These are some areas where we apply the machine learning in the real time. So in machine learning, we have three different approaches. Those are called machine learning paradigm. Paradigm means in which way we do something, that is called a paradigm. So machine learning approaches or machine learning paradigms, they are classified into three types. One is supervised, second one is unsupervised, and third one is reinforcement. So let us have a brief look on supervised learning. So in supervised learning, the training data consists of set of training examples. So the data which we fed to the machine, that is called training data. So data, it consists of a number of observations. Data is nothing but a collection of number of observations. So that is called training example. So we divide the data into two parts. One is training data and second one is test data. We do not give the total data to build the model. That is not the correct approach. Some part of the data we use to build the model, and some part of the data we use for testing purpose. That's why the data is split into two parts. One is training and second one is testing. Same data only. So in each example or in each observation, there is a pair consisting of input object and desired output value. That's what I have discussed earlier. Say, let us suppose you take the example of house price prediction. There we have many features or attributes like area, bedrooms, and how old it is, and the price. So every instance of that particular data, it consists of the values of all these attributes. Okay. So, and we can divide each of that example or observation into two parts. One is input, second one is desired output. Input means input attributes or features which are independent, sorry, and the output is the independent one. For example, area, number of bedrooms, and the how old the house is. Those are nothing but input values or input features. The price is nothing but output value or output feature. Like that, we can label the data. So that is the main important thing in supervised learning. So here in this diagram, we can observe we have some data, that is past historical data. So the training data, we split the data into two parts. One is training data set and second one is test set. First one is training set, second one is test set. So in every data instance or observation, we have again two parts. We can just interpret as a pair. So one is input or non-target attributes, second one is output or target attribute. So we have each of this observation is called one instance. Every instance, it consists of a pair. One is input object and second one is output. Here just I have given the notation. So x1 means we should not think that it is a single value. It is a vector. Vector means it may have more than one value also. It is non-empty. It may contain one or more features. In this example, our area, our how old the house is, how many number of bedrooms that house has, these are all comes under input x1. y1 is nothing but the price. We have to interpret like that. So some part of the data we use as training purpose, and we fed the machine learning algorithm with this data. We fed this data to the machine learning algorithm. Then from this it builds a model. So then we give some new instant input x. That means from this testing set we give this input to the model. First we train the machine, we train the model using some machine learning algorithm. Once the model is built, then we give the test data to this model. Then it will predict using this model for the given input value x1 dash, x2 dash, x3 dash. It gives some output value. So we can observe here either training set or testing set. We have some input features and the corresponding output value. Here also we have input features and corresponding output. X1 is nothing but your input features. Y1 is nothing but output value or target value. In testing also we have input values x1 dash, x2 dash, x3 dash and corresponding output values y1 dash, y2 dash and y3 dash. First we train the machine using the training data, then it builds the model. Then we give the test data to this machine. In the test data we give the inputs x1 dash, x2 dash, x3 dash. Then it predicts using this model. So then what we do, we compare these values y1 dash and the predicted value, y2 dash and actual predicted value, y3 dash the actual value and the predicted value. That is called validation of the model. So this is the overall view of this particular supervised learning approach. First we train the machine using the training data, then we give some new data, new instances, data instances, and it predicts some output. Then we just do the validation. What is the actual variation between the predicted value and the actual output? That is the approach called supervised learning. So supervised learning algorithm, how it works actually, analyzes the training data and produces an inferred function which is called a model or a hypothesis. Actually it is a mapping between your input and output. That's it. We have two popular supervised learning methods. One is regression, second one is classification. So what is the difference between these two? Actually I told you that, so in every observation we have some input instance and the corresponding output. If the output is continuous, then we use the regression. If the output is categorical, then we use the classification. For example, in case of the house price prediction, the output is nothing but the price of the house. So it may take any value. There are no fixed values. The house price, it could be any value. That is called continuous. Continuous means it takes any value. But classification, it takes some specific values which are called categorical output. Let me give one simple example. Let us say I want to analyze the data of some players, cricket players, where we have the data, number of matches a player he played, and how many numbers, how many runs he has scored, how many wickets he has taken. That is our data actually. So using the data we can analyze, and the output is the player. He may be a bowler, he may be a batsman, he may be an all-rounder. So that is called categorical output. So then I give some data, runs, wickets taken, matches played. Then it will predict what type of class he belongs to, whether he is a bowler, he is a batsman, or he is an all-rounder. So you may give any input instance, but the output is one of those categories. That is called classification. I hope I am clear. What is supervised learning? What are the popular approach? There are two approaches, regression and classification. So let us suppose to just classification of mails, spam and not spam. That is also one type of classification problem only. So next, whether a particular customer, he will choose a particular policy or not. That is also one type of classification. So for example, a person to whom he is going to vote for, that is also some classification. There are some parties, he may vote for any party. These type of problems are called classification problems and regression techniques. So next one is unsupervised learning. So in unsupervised learning, we discover the patterns in the data. So that is called unsupervised learning mechanism. Here we have only data input instances, but there is no labeled output for this. So we fed the algorithm with this data, and from this data it will discover some patterns in the data, some type of patterns. Then if I give a new input instance, then it will set a particular cluster for that particular data. So this is nothing but discovering the patterns in the data. How does it discover the patterns? Using the features. So in unsupervised learning, very important task is identifying the features. Let me take an example. There are some fruits with different colors and different sizes. We have some apples, cherry, banana, and grape, let us say. So there are some features for each of those. What is the color, what is the size, like that. So here, so identify the features first. Let me take first the color. So obviously apples and cherries are in red color, grape and banana, they are in green color. So first feature to classify them, to cluster them, that is nothing but the color. Second one is size. Let us suppose apple and cherry, they are in the same cluster, and banana and grape are in another cluster. Again in that cluster we have to identify whether the fruit is apple or cherry. So then we take the second feature called size. Like that, there is no labeling of data. So just we form the cluster based on similar features. That is called unsupervised learning. There is no input corresponding output. There is no labeling of the data. That is nothing but unsupervised learning. For example, you have given a set of images. From that, you need to identify animals, humans, like that. that comes under unsupervised learning. So in unsupervised learning, we have two methods. One is clustering and association. So clustering is nothing but cohesive grouping, similar properties. The objects with similar properties, they are made as one particular cluster. Second one is association based. So association based means identifying the similar patterns. That is called frequent co-occurrence. So these are the two popular methods of unsupervised learning. In our entire machine learning, so we learn these supervised learning, these two techniques, and unsupervised learning, these two techniques. There are some standard algorithms for each of these techniques. We have logistic regression, linear regression, k-means clustering, like that. So third important one is reinforcement learning. So in reinforcement learning, there is no input, there is no output. This particular machine or agent, it learns by performing the actions and observing the result. That's it. Like robots. So robots, what do? They move in any direction. If some obstacle comes, they change the direction automatically. How it is happening? So performing some action and observing the results. That's it. That is called reinforcement learning. So it is one type of machine learning where an agent learns. Here agent, it can be a software component also. Agent maybe it is a software component or anything. It learns to behave in an environment. Here environment means what are the external things. Those are all called environment. So it performs some actions and observes the results. That's it. That is called reinforcement learning. So these are the three different approaches or popular approaches of machine learning. So then why Python is used for AI and ML applications? In industry, now it's the very trending technology. So building AI and machine learning applications using Python. Then why Python? Why not some other language? So there are some reasons why Python is chosen and Python is preferred. Some of them just I have listed here. Python is very simple to learn and easy to use. That is the first feature of this one. It is very simple to learn and very easy to use. There is no prior programming experience is required for learning Python. There is no prerequisite. It can be your first programming language to learn. That much simple this particular language. That's why anyone can learn this Python language. So Python, it has built-in library support to develop any type of applications. So inbuilt, there are some built-in modules, packages, libraries available in Python, and there are some third-party libraries which are compatible with your Python applications. They are also available. External packages are third-party packages, libraries also available. For example, to build any machine learning applications, we need some libraries called pandas, numpy, matplotlib, seaborn. They're all external libraries. They support this Python programming language. That's why we can develop the applications very easily. Next is concise code. Here the lines of code are less compared to any other programming language. Then we can do the same task using some other languages like Java and other languages. But here the lines of code compared to other programming languages very less. And there are many other features of Python why we need this language. For example, it is platform independent. So we can write the Python program on one platform and we can run that application on any platform. That is one reason. And next one is it is an open source. Open source means it is available at free of cost and we can customize that one. That is called open source. We can contribute to the community. Let us suppose there are many built-in libraries in Python and third-party libraries also, external libraries also available for Python. Those libraries they were not developed by us. Some other people they developed and they wrote some functions and they provided us. Like that, time can be reduced and sophisticated mechanism for developing any type of complex applications. That is the one of the important thing regarding this open source softwares. Open source means the source code is available to public. It's made available to all. One can use the code and one can customize it and contribute to the community. That's about this Python, why we choose this Python language. So to build any machine learning and AI applications, we use one popular IDE that is called Jupyter Notebook. So here, just let me introduce that environment of Jupyter Notebook. Here, just I will open. There are many IDEs available in the industry, so we can use any one of them. But the most popular one is Jupyter Notebook. So here let us get acquainted with the environment of Jupyter Notebook and how to write some sample code. Just I will give a simple demonstration on this. So to develop any machine learning and AI applications, we need some external libraries. So we can use PyCharm, Jupyter, any IDE. But what is the advantage of this Jupyter Notebook is? So once we install this Anaconda software, all external libraries they get installed and we can directly use. No need to set any class path or nothing. Directly we can use it. So that is the one of the advantage, and it's very simple to use. That's why most of the people they prefer this Jupyter Notebook. For example, I want to use some of the external libraries available. So first I want to use one library, NumPy. NumPy and Pandas, these two are very important libraries to develop any machine learning application. So here NumPy, it is called numerical Python. It is one of the built-in external library. So first, if I want to use any library or package or module in my program, first I need to import. That's why I use the keyword called import. So we are importing a particular library in our application. So a library, it consists of classes, functions, many more things. Okay. Actually, a module in Python is nothing but a simple Python source file. It may contain some functions, classes, some constants. So a group of modules, they are all grouped under a particular package. So generally a library, it may contain more than one package, but we use oftenly this library and package interchangeably, then no issue. So NumPy is a library, or let me call it as package. If I want to use any of the functions or any of the classes of that library, then I must use this name of this particular library, NumPy. Always in my program, I don't want to use this name NumPy. That's why I want to give one alias name that is called NP. Import NumPy as NP. We are importing this particular package in my application. Wherever I need to refer this package name, then I am going to use the alias name NP. That's it. Next, Shift plus Enter to run any instruction or code. So this is called one cell where the cursor is blinking. This is called one active cell. So in active cell we write the Python code, and if I want to run this, just press shift enter, then the code is run. Now actually NumPy, it is a very powerful tool for mathematical computations, numerical Python. So the fundamental object of NumPy is called ND array. So we can create arrays using NumPy. So we can create multi-dimensional arrays and we can perform some operations, linear algebra operations, some Fourier transformations. Like that we can do many mathematical operations using NumPy. That's why whenever you want to develop any machine learning based AI applications, first you should get acquainted with this particular library, then followed by pandas, then followed by matplotlib and cbar. That is the learning path. For example, in this particular NumPy, there is an object called ND array. So first I want to create a two-dimensional array, ARR, two-dimensional array, ARR underscore 2D is equal to NP dot array of. Here, NP is alias name for NumPy. NumPy is a library. In this library, I want to use this particular function called array. So that's why I must use the name of that particular package np, because I am aliasing it as np. If I don't do this, then I must use the name numpy here itself. Now I want to create a two-dimensional array. Here it expects one argument, that is nothing but any of the Python built-in objects. So for example, I want to create a two-dimensional array by passing a nested list. A list is a Python's data structure where it is a collection of items. That's it. A list is nothing but a collection of objects, indexed objects. Indexing is provided. It may be heterogeneous also. So for example, I want to create an array that is a two-dimensional array 1, 2, 3, 4 and 5, 6. That's it. 1, 2, 3, 4, 5 and 6. So here I want to create a two-dimensional array with 3 rows and 2 columns in each row. Here this one is called a Python's data structure, that is called nested list. Just simply press shift enter. One, two, three, four. Here it should be comma, because objects are separated by commas. Just comma here. Yeah, now it will be okay. Just shift enter. That's it. So your instruction has been successfully executed. If any error, then it displays in the next cell. Okay. So now what I want to do in this, I am creating a two-dimensional array object of NumPy. That's it. Just I want to print this particular array ARR underscore 2D, shift enter. Now I am getting the output array 1, 2, 3, 4, 5, 6. Then you may get one question, sir, here also same, here also same, what is the difference? Yeah, there is a lot of difference. Here it is a nested list, which is Python inbuilt data structure, but here it is an array object of NumPy. It displays in the same manner, but the internal storage, internal representation, it is different. That's why array objects of NumPy, they are performance wise, they are very good compared to Python's nested lists. The data types representation and the operations which we perform on this array objects of NumPy, there are many other things. Anyhow, performance wise, NumPy array is very good compared to this Python's nested list. So now there are certain attributes we can check here. ARR underscore 2D dot. So here I want to check size. Size is 6. There are total 6 elements in this array. So size is one attribute and it will give you the number of elements in this particular two-dimensional array. For example, shape arr 2d dot shape. Shape is another attribute which gives the number of rows and number of columns. Okay, so shape, it gives the dimensions of the particular array. So 3 rows and 2 columns. Next one, item size. Item size. Size, it gives the number of elements in the array. Then what is item size? It will give the size of each of the element of the array. So here we can see the size of each of the element is 4 bytes. 4 bytes. 4 bytes means 32 bits. Just here there is one more attribute called d type. D type means data type. Here all these elements are of which type? Integer 32 type. This is one of the data type. Int 32, float 64, object, these are the Python, pandas or numpy data types. So the internal representation is int 32. 1, 2, 3, 4, 5, 6. Each of this particular element, it occupies 4 bytes of memory, and each of the element, its type is int 32 type. So in case of this nested list, each of this one, its type is object type, and its storage also it's different. So that's why performance wise this numpy arrays are very good compared to the Python lists. So like that we have different attributes we can use here, and in different ways we can create the arrays also. For example, arr underscore 2d is equal to np dot arrange of, here you can specify the range 1 to 10 dot reshape. There are total 10 elements, 2 comma 5. So we are 10 elements, 2 rows. In each row we have 5 columns. Just let me give just arrange first. Arrange is a function which gives the values within that range. So actually arrange is a function. So here you can specify the begin value, end value. It will generate a list of values within that range 1 to 9. So that's about this particular arrange function. We can create a single dimension array like this. Okay, but you can convert into any other dimension. For example, 1 to 7, total 6 dot reshape of 3 comma 2. Shift enter. You want to modify the code and do it? Yes. Now we have got it. So np dot arrange function, first it generates a single list of values within this range. Last value is excluded. Okay. So already we have seen 1, 2, 3, 4, 5, 6. A single linear list of values it will generate np dot arrange. Then we are using one function called reshape. So first arrange function, it generates a linear list of values 1D array, and then we can reshape it with our desired rows and columns. For example, it generates total 6 values. I want to convert into 3 by 2 matrix. That's how we can create it. So actually for many applications we generate like this. Automatically we generate within a range of values, then we reshape it as a two-dimensional array. So this is a simple practical so it is a practical demonstration of this environment, how to use this Jupyter notebook and all. So with this, let me conclude this session. It is just an introduction to AI machine learning and Python language. What are the advantages of using Python, and get acquainted with the Jupyter notebook environment. So any queries from any of the participants, I am very happy to answer. Now it's open for discussion. Anybody, you can ask any queries. Yeah. Any queries? Any? No queries? Then thank you.
They will post in the chat window.
Here?
You mentioned that.
Well, already I have displayed the slide. Okay, live chat. Okay. Here now I have to type. This one? Live chat. It's stream ended. Live chat. Okay. The edit, sir. Yes. Live chat. Any queries? Yeah. Please, you can type your queries on live chat. So I am going to answer.
So how to implement AI using Python? That is question.
Yeah, and Datta.
Mayanak Datta.
Yeah, yes, Manak Datta sir, you have one query. How to implement AI and ML using Python? That's your query. Yes. So the path to learn and implement this AI ML is, first we have to learn the essentials of Python to implement the AI and ML. So you no need to learn each and every concept of Python programming. There are certain topics essentials for machine learning and AI application development. So those are basic data types and built-in data structures, functions. That's it. If you learn only those concepts of Python language, that's enough. Then the second step is, that is the first step. You must have some basic idea on Python programming language. Only those topics are enough. Second one is, then we have to learn the external libraries like NumPy, Pandas, Matplotlib, and Seaboard. Actually, NumPy, it is used for numerical computations, some linear algebra operations, and Pandas, it is used for data pre-processing. Actually, the most important crucial task in machine learning is data pre-processing. Why? Because we have various resources where we get the data. In real world, the data, it consists of some noise and missing values, invalid entries. First we have to clean the data. For that purpose we use the Pandas. Pandas is used for data pre-processing. That is a very important module. Then we have to train the model using this particular clean data. So we have different libraries available in Python, in SQL land. In SQL library, we can use some modules and built-in functions to build the model, and we fit the data into the model. Then finally we give the test data for validation. Actually, we have to split the data into training and testing. That thing also we can do, train test split method, that is available. So first step is splitting the data, training and testing. First, data pre-processing. Before splitting it, first data pre-processing is required using pandas. Then we split the data into training and testing. Third step is we train the model using the training data. Fourth step is we validate that model by passing the test data. These are the this is the actual learning path. I hope I am clear.
One more question.
One more query. Yeah.
What is the difference between
Data science and machine learning, there is a slight variation and it's a slight difference. In data science, we always focus on the insights of data. That's it. Data insights, hidden patterns, we always identify. There we use different statistical methods for identifying that correlations, regressions, and normalizations. We use different techniques to identify the hidden patterns of the data, deep insights of data. That is about data science. In machine learning, it is much more. We do this thing also, but we have different types of approaches. What I discussed, like supervised, unsupervised, clustering. There are many other things we do in machine learning. So data science and machine learning, AI, all are related, but specifically in data science, we focus on identifying the data patterns and deep insights using some other programming language called R and all. In machine learning, it is a practical implementation of AI. In AI, we study different techniques like optimal searches and all. We implement that particular AI theoretical concepts in machine learning using the standard algorithms. We write some program and code. That is the major difference between data science and machine learning. I hope, am I clear? Much more bigger machine learning is than data science. Any query?
In unsupervised learning,
Yeah.
give one example of association method.
Association, yes, I will tell you. For example, there is one retail industry called Walmart. So Walmart is the top one company in this world where they use this machine learning data science technique day to day transactions. For example, a particular customer comes and he buys bread and butter, let us suppose. So the customers who buys bread, they also buy the butter. The customer who buys bread and butter, they also buy some fruits. Let us suppose that is called buying trends of the customers. What they do is, in a particular season and particular occasion, what is the buying trends of a particular customers? That is called association. If a particular customer he buys some product, he also buys some other product. That is called association. What is the association? Using that, they will find the buying trends. They will get the stock and they sell it. They get the profits. How the Walmart is the top one in the Fortune 500 companies since many years. That is the technique they are using. That's why it is very important. And one more thing, we can identify the outliers using this association and all. That is also used by the Federal Bank of US and all. These are they have the many real-time applications for association and outlier analysis and all. That's why this machine learning is very popular.
When we use the TensorFlow library.
Yes, TensorFlow actually we use for deep learning concepts. Actually, machine learning is subset of AI. Again, deep learning is subset of ML. So in some there are some limitations for machine learning, where if the data its populated data is grows much more bigger and bigger huge, then your machine learning model it may not work efficiently. That's why what we do, we build the layers of this data transformation that we do in the deep learning. So in deep learning, to write the applications for deep learning, there we use the TensorFlow. So TensorFlow, it is also open source, available from Google. That is a very good package developed by them. So we use in deep learning actually TensorFlow.
One more question. Sir, Google Colab is
Yes.
used instead of Jupyter.
Yes. Instead of Jupyter, you can use Google Colab also. For you want to develop any large scale projects and all, it is better to use your own Jupyter. You install it and you build your application and you do all deployment all. But we can use Google Colab also.
One more question. Sir, any applications of AI and ML using Python in the field of medicine?
Yes, sir. Lot of applications. For example, nowadays we can see doctors cannot have a physical interaction with patients. Then they are using online that advice of medicine and all. How do they do? Actually, they take the test reports of the patients, they feed into one model. Then it will give the prediction and they can suggest the appropriate medicine. That is already used in medical field. For example, how likely to get a particular disease if I give some parameters of their cholesterol level and all. It is widely used in medical science and medical industry.
In supervised learning paradigm, give an example of regression method.
Yes, regression method. I give one a simple example. Whatever I have given, that is the example of regression only. Actually, for example, this house price prediction, what I discussed, that is an example of linear regression itself. Because there are some dependent variable. If there is a linear relationship between dependent and independent variables, there we use the linear regression. For example, you want to predict Indian economy for the next year using the past historical data of last 20 years. That is a linear regression. For example, you want to predict the price of car, selling price of a car, where we have certain parameters like what is the how many kilometers it has traveled, so how much fuel it will consume. Those are all independent values, and the selling price is the dependent value. If we want to find the relationship between dependent and independent variables and the relationship also linear relationship, then we go for the linear regression model. There are many examples we have for linear regression. One is like prediction of this, for example, COVID-19 prediction, that is also comes under linear regression. How the trends of this COVID-19 in this world, that is also one of the application of linear regression only.
Sir, you mentioned Jupyter link. They are asking Jupyter link.
So yeah, I would suggest you to please go to Anaconda. Otherwise, I can show Anaconda Navigator. You type on Google search bar. Directly you can install. First, you have to install Anaconda software. Then automatically you will get the Jupyter notebook.
Last question. Okay. Last two questions, sir. We'll close the questions.
Okay.
Feature extraction and feature selection of
Yeah.
data set. How to extract the useful data set columns from the available data sets.
Yes.
In Coggle using Python.
Yes. But actually in Coggle, it is a huge repository. It consists of data sets. First, we have to download the data sets from the Coggle site where the CSV formats are available. So once we get the CSV format data, first we load the data into data frames using pandas. There we have many functions to extract the features, to extract, slice the data, slice the particular observations. We have many methods there available where we can extract the useful features. We can drop some of the features. These things we can do using pandas. That's why pandas is very important library to build any machine learning application, where we do all these things: extraction of useful features and removing unnecessary columns and data. We can do all these things. We can modify it. That we do in pandas.
The last question, sir. What is meant by diversity of ML model and the maturity of ML model? Maturity of ML model.
Yes, that is called validation of the model. Whatever the question asked by the participant, that is called a model validation. That we use one function called score function for validation of this particular diversity of the model. So how close it is, how proximity it is, and what is the probability of getting the accurate result. That thing we use one method called score method to validate it. So that thing, once we learn this course, there we learn all this step by step. Just I have whatever I have given the practical demonstration, that is to show you the environment of Jupyter, and that's it. Many more things we should learn to build any real-time application. There, pandas is very important. Considering all this NumPy and all other, pandas module is very that package is very important. There all we have cleaning and removing unnecessary data, everything we can do, and validation of that model, that thing we do.
Fine, sir. In chat window, we are sharing your mail ID. There is some
live chat.
చేశాను.
చేశారు. ఓకే. కేఎల్ మెయిల్.
Participants in chat window.
So, dear participants, in chat window, I type my. In chat window, you can reach me on rameshkumar.majada rameshkumar.mojjada@kaleuniversity.in. So you can reach me on this. I will answer all your queries. So in this lecture, yes, I thank our university authorities and Pantech Solutions and all enthusiastic participants who have given me the great opportunity to share my knowledge. In this 1 hour, just I tried my level best to get acquainted with this particular emerging technology. So any queries, you can reach me on my mail. Up to?
Sir, is there any upper level up to which ML cloud?
Yes, sir. Actually, machine learning. Again, we have next level deep learning. In the next level, we have computer vision. In the next level, we have sequence learning. In the next level, we have natural language processing. Many more, many more. Almost all every industry in every top company, they are spending a lot of amount on research of this AI and machine learning. So there are many other technologies, advanced technologies. They are based on AI and machine learning. One of the most popular one is Alexa and natural language processing, Google Assistants. These are all some of the applications. Tesla driverless cars. There are many more applications. There is no limit. If you have the idea, robotics based drones, whatnot, everything. Yes. Yes. Let us close the session. Once again, I thank all the participants and my university officials and the Pantech Solutions, the members of Pantech Solutions. Thank you one and all. Have a great day. And end stream.